If you're a developer who's ever asked yourself what's the best way to fetch data efficiently in Next.js, should I use useEffect or a server component? When should I use something like TanStack Query? You're in the right place. In this video, we're going to break down 6 different ways to fetch data in React and Next.js, from basic to advanced, and show you how they work under the hood, when to use each one, and pros and cons of each approach. First method, client-side fetching. Alright, we have a brand new Next.js application, and let's start off with the most fundamental way to fetch data in a React component, using the useEffect and useState hooks. If we use useEffect or useState, we have to mark the page as a client component, meaning the browser will fetch the data after the initial page load or after the component mounts on the client side. So, what's happening here? We have to-dos, loading, and error states, and this useEffect basically runs when the component mounts and fetches to-dos through the fetch to-dos async function. This function retrieves fake to-dos with this mock API provided by JSON placeholder, and yeah, inside the fetch to-dos function we set loading to true, make our API call, and this call will be very fast, so just to simulate a real database call or whatever, we delay it by 3 seconds. Then we update the to-do state with a response or set an error if something goes wrong. Finally, we set the loading to false. Let's see this in action. I just have the application here. I refresh the page, and when the component mounts, just useEffect doing its work. So every time I refresh the page, I see the loading penny state. After the 3 seconds, we have our to-do list. Pro and cons of this approach. About the pros, we have that it's just simple for basic cases. It's great for understanding core React concepts like state and useEffects, and it just works in any vanilla React application. It's not strictly tied to Next.js. On the other hand, we have different cons to be aware of. For example, manual state management. Imagine you have to fetch data in multiple pages or multiple components. You have to write the logic for loading, error, and data states yourself every single time. If you need to fetch data in many components, this boilerplate code can add up, making your code base harder to scale and test. This approach, as you see, fetches data every time the component mounts, unless you add caching logic yourself. Implementing caching by yourself can be complex, especially if you're a junior developer. Another cons is that this approach is just client-side. Data is fetched after the page loads, which might not be ideal for SEO because search engine might see an empty or incomplete page if they don't wait for the JavaScript to execute. Data waterfalls. This pattern can lead to waterfalls if you're not careful. A waterfall is when you have sequential network requests that depend on each other, slowing down the data loads. For example, imagine you fetch user info. Then you have to fetch something using the user ID. Then you fetch the post based on the user ID. Then you fetch the comments based on the post ID. Each step waits for the previous one, and this makes your UI feel very slow. Method 2, server components. Now, if you're using Next.js, things get a lot cooler with server components. Server components run on the server, they get the data they need, inject those data in the HTML, and then send the HTML back to the client. Back to our code, I extracted the getToDos function in this separate utils file, and then this is our new page.tsx file. What's happening here? Our component, our main component, our page is now async. This only works in Next.js server components, which means data is fetched on the server before the page is sent to the browser. There is no useState, no useEffect, no loading states in the component. It's just really straightforward. Let's try it out. So if I take our page, I refresh the page, I see that I have to wait 3 seconds before getting my data. Let's try again. I refresh the page, I have to wait 3 seconds, and then boom, I get the data. Pros and cons of this approach. It's just simplified data fetching. In this way, the code is much cleaner. We have the powerful server-side rendering, or SSR, where data is fetched on the server. So the page arrives at the client with the content already in there. And it's great for SEO because search engine gets fully rendered HTML, making it easier to index your content, and is also great for performance because the browser doesn't have to wait for the JavaScript to load. As a consequence, less client-side JavaScript means less work for the browser. Also, we have the Next.js built-in caching, and if you need data across multiple components, it's just great. On the other hand, SSR is just Next.js specific. It doesn't work in vanilla React applications or other frameworks. Another problem might be the blocking rendering potentially. If the data fetched inside the server component is low, it blocks the rendering of the entire component. So the user waits longer just for the initial HTML. We'll address this later with React Suspense, but in our example, we have to wait 3 seconds before getting our data. It's not ideal for user experience. Last cons is less client-side interactivity by default. Server components are primarily for rendering UI. If you need client-side interactivity for this component, for example, a button to refetch to-dos, form submissions, you will typically extract that interactive part into a client component, marking it with use client, and potentially use Next.js server action or route handlers for mutation. But these are more advanced concepts we're not covering in today's video. Third method, server components plus suspense for better UX. One of the downside of the previous approach was that a slow data fetch can block the entire page render. Just remember the 3 seconds we were waiting before getting the data. Imagine waiting 5-6 seconds every time. That's not ideal. To fix this, we can use React Suspense. Suspense lets show you a fallback UI, like a loading spinner maybe, for those parts of your page or your component that are waiting data from the server, while other parts of the page that don't need those data can be rendered and be interactive without problem. This gives you the benefits of server-side rendering while providing better loading states and user experience. Here I separated the whole to-dos logic in a separate component in this new components folder. Then our new page.tsx file looks like this. What's happening here? Now, when to-dos component is fetching data, the rest of the home page, like this H1, will be rendered and sent to the browser immediately without waiting the 3 seconds, because in place of this to-dos component, we have the fallback UI, our suspense. Once get-to-dos in to-dos component resolves, in this case, in our component, Next.js will send a rendered HTML for this component to the client, replacing our previous fallback. And yeah, it's just great for UX. Let's try it out. So if I get here, I refresh the page, I don't have to wait the 3 seconds, and I see immediately our H1 to-do list. In the background, our server component does its job and retrieves the data from our database. Pros and cons of this approach. Pros: improved user experience. No more waiting for the entire page if one part is low. Data fetching is still server-side rendered. As a consequence, less client-side JavaScript, so less work for the browser, as we said previously. Next.js built-in caching still applies, so it's just great. Cons: suspense for data fetching is still experimental in some setups and in some Next.js version. Like before, this approach is still Next.js specific because we still use SSR. So if you want to use just vanilla React, you can't use this method. Error handling. You need to use Next.js error.tsx file convention or React error boundaries to catch errors from suspended components. This maybe will add more boilerplate code. New React use hook. React 18 introduced a new hook called use. It allows components to read or consume the value of a promise, and it integrates very smoothly with the suspense we seen before. This is often used in client components that receive a promise as a prop. In this case, we create the promise in the parent component, like our homepage, and this initiates the data fetch on the server. In this case, the getToDo's function does not return the data because we are not async it or awaiting it, and it just returns the promise. We just need the promise because we pass it to the ToDo's component as a prop. ToDo's component uses this new use hook to consume this promise. While the promise is still pending, React replaces the rendering of this ToDo's component with the suspense we see before in the previous method. Once the promise resolves, the ToDo's component renders. We just have to see that in action in a moment. Right there, if I refresh the page, we have to wait the 3 seconds, and then this is it. Why this method is so powerful? Because we can use that in client components, making it super flexible. And it integrates very smoothly with the React suspense and is great for having our fallback UI. Cons here are just that we always require a suspense boundary. The component using use with a promise must always be wrapped in suspense. And it doesn't handle caching or refreshing itself. The use hook doesn't add caching logic. For refetching, you will typically need to provide a new promise to the use hook. It might get overcomplicated, and this is where libraries like TanStack Query often offer more capabilities. React Context API. Imagine you need these to-dos in multiple components. If we use the last approach, for each component, we'll need to pass the promise, consume the promise, and we could overcomplicate the code. And yeah, we are good developers, so we want to avoid prop drilling if we can. Here comes the React Context API, or maybe you can use other state management tools like Redux, Zustand. In this case, we just stick to React Context API. I created my ToDo's context provider here and used it to wrap all my layout right here in my layout.tsx file. So what's happening here? This pattern allows you to fetch data once on higher level, in this case in our layout.tsx file, and make the promise available to any client component down the tree that needs it without prop drilling. This pattern shines in larger application where the same data needs to be accessed by multiple components at different nesting levels. Let's see that in action. If I refresh the page, the result might look the same, but there are several pros on this approach. For example, it avoids prop drilling for promises. If you need those data multiple components, it will be great to centralize the logic for data fetching. Like in this case, we just fetch the data at an higher level and make the promise available to other client components. It's just great, and it works well with suspense for loading states. There are also some cons. On the other hand, it just adds complexity and more boilerplate and setup code is required, and it might be not worth it for single component applications. Context overhead. Every consumer re-renders when the context changes, or maybe there is more debugging complexity. It's maybe harder to trace data flow in larger applications. The last method is using some data fetching libraries like TanStack Query. As applications grow, managing server state or data that comes from an API with just useEffect or even the useHook plus suspense can become a real challenge. You start asking, how do I cache this data to avoid the refetching? How do I keep it fresh? What about background updates? How do I handle mutations, post, put, delete, and update the UI? This is where dedicated data fetching libraries like TanStack Query become incredibly powerful. On this example, we'll focus on TanStack Query. I've used it in projects like ResumeMatcher. You can find that in earlier YouTube videos on the channel. TanStack Query is a beast for managing async state, offering caching, automatic refetching, dev tools, and so much more out of the box. To use TanStack, you obviously have to install it. So these are the commands to install TanStack on your on your project, and then I just created this query client.ts file. I wrapped all my layout with the query client provider, passing the query client here as a prop, and then we have our new page.tsx that is super clean. We just have this to-dos component. This is our new to-dos component. Let's break it down. We have this use query function, and our query key is just the crucial part, and because TanStack Query uses this key to cache the data. If another component calls use query with the same key, it will get the cached data. Query function is just our actual async function that fetches our to-dos. The return values are the actual data, our resolved data is loading, error, for error handling, and this refetch, a function that manually trigger a refetch. As you see, TanStack provides us with all the necessary to handle loading state, error messages, and so on. TanStack Query automatically caches data. Let's break down this query client component. Stale time. Data is considered fresh for this duration. If you request to do it again within this time, you get the cache instantly. After stale time, data is considered stale, and if data is stale, TanStack Query will give you the stale data from the cache immediately, so the UI updates fast, and it will refetch in the background. Once the fresh data arrives, it updates the UI. It's just amazing. And this GC time is garbage collection time, and is just how long inactive query data stays in memory. For an even better initial load experience in Next.js, you can prefetch data on the server and hydrate it on the client. The data will be available in the TanStack Query cache before your client component even tries to fetch it. This is simple, but advanced concepts about TanStack Query that may require another video. Pros and cons of this approach. Pros is just that this method is ideal for robust data management. It handles caching, background updates, revalidation, error handling, loading states, and much more out of the box. Because of that, it just reduces boilerplate. Also, the dev tools are amazing, and there are just some excellent developer tools for inspecting query states, cache, and its behavior. And it works both in React and Next.js. It's very versatile and integrates very well with server-side rendering and prefetching patterns. Right now, I would not suggest to use TanStack Query only if your app only fetches data once on a single page without needing caching or advanced features. In this case, TanStack Query might be a bit more of what you really need. Alright, we covered a lot today. We just see from the basic use effect to sophisticated libraries like TanStack Query. My advice is just start with the simplest approach that meets your needs. As your application grows or your requirements become more complex, explore these more advanced patterns and libraries. I hope this breakdown helps you navigate the world of data fetching in Next.js and in React also. And yeah, if you found this video helpful, please give it a thumbs up, subscribe for more content, and hit that bell icon so you don't miss the next one. Thanks for watching, and happy coding!